May 1945. Germany has surrendered. And across Europe, there are airfields packed with German warplanes, fighters, bombers, even jets, just sitting there like someone hit pause. No crews, no fuel, no clear orders. So here's the question. What happened to all those Luftwaffe planes after World War II ended? Most people imagine they were captured and flown away like trophies. Some were. But for most of them, the ending was much harsher and way more industrial. In the final weeks, many planes were simply abandoned because the Luftwaffe was collapsing and fuel was running out. Then the Allies stepped in with strict orders to erase German air power for good. A small number of aircraft were spared because they were too valuable to ignore, and their secrets helped shape the next era of aviation. Here's what you're about to see. First, the ghost fleet of abandoned planes. Then the cleanup, scrapyards, crushing and melting. Then the rare survivors. And finally, the hidden story most people miss. The secret race to steal German jet tech, blueprints, and the people who knew how it worked. When Germany surrendered in May 1945, thousands of Luftwaffe aircraft sat abandoned across Europe. It was the collapse of what had once been a feared air force. By war's end, nearly 40,000 planes had been completely destroyed, with total losses exceeding 75,000 aircraft. If you had walked those airfields, you would have seen famous fighters like the Bf 109, produced in 34,248 units, and the Focke-Wulf 190 scattered around, made useless by fuel shortages, bombed facilities, and a lack of pilots. These were the planes that once ruled the skies and built a terrifying reputation. Luftwaffe records show 63,324 claims made during the entire war. But now, even those victory machines were stuck on the ground. Even advanced aircraft were stranded. The HE-219 night fighter, 268 built, and the high-speed DO-335 Pfeil, 37 built, also stood grounded. In the Luftwaffe's final days, there were desperate evacuation attempts using Ju-52 transports on May 8th to 9th. After that, personnel fled and equipment was abandoned. What remained of Germany's air power disintegrated almost overnight. As Allied forces advanced across Europe in spring 1945, the scene got even stranger. Hundreds of Luftwaffe aircraft were abandoned at airfields from Norway to Austria, their tanks empty and crews long gone. The command structure had collapsed, with squadron leaders surrendering to whatever Allied units they met first. That meant there was no coordinated plan for what to do with the massive fleet. And without fuel deliveries for weeks before surrender, even aircraft that were technically ready could not take off. So the continent filled with sudden aircraft graveyards. The Luftwaffe's last big offensive, Operation Bodenplatte, had already drained their remaining experienced pilots and usable aircraft. By the end, it wasn't just defeat, it was paralysis. When the Third Reich collapsed in May 1945, abandoned Luftwaffe airfields stretched across Europe like a haunting map of retreat and disorder. By war's end, there were 682 German airfields, with 70 bases around Berlin and Brandenburg alone. That's a huge footprint, and it was suddenly packed with wrecks, scraps, and aircraft that would never fly again. At Kaltenkirchen, chaos reigned as personnel fled, leaving underage TK Mädels and Luftwaffe Helferinnen stranded without orders. This place carried a darker shadow too. The site where SS forces had executed Serbian POWs would later be reforested with 2 million trees. Kaltenkirchen had hosted several operational Me-262 jets by February 1945, and those jets were abandoned or destroyed before the Allies arrived. Across these ghostly facilities, you'd see cratered runways, bombed-out buildings and aircraft carcasses, Junkers, Messerschmitts and Focke-Wulfs, left where they stood. Many sites stayed dangerous for decades, others turned into refugee housing or military grounds. Over time, their wartime purpose faded. The abandoned airfields were only part of the Luftwaffe's breakdown. Behind the scenes, the leadership chain had fallen apart. By war's end, Göring's leadership had turned into unpredictable behavior and empty promises. Once respected by many officers, he slid into brutal orders, favoritism, and bad promotions. Even his art collecting pulled attention away from the military disaster unfolding. When Hitler stripped Göring of rank for treason in April 1945, it only made official what was already true. Operation Bodenplatte in January 1945 showed the dysfunction, desperate, costly, and losing leaders like Helmut Kühler. Communication broke down as mixed, conflicting orders flooded a shattered chain of command. With key leaders killed, captured, or transferred, the remaining aircraft sat useless. Fuel was the invisible weapon that finished the Luftwaffe long before the final surrender. Allied bombing targeted Germany's synthetic fuel plants and choked off the supply needed to fly. By spring 1945, you could have seen thousands of serviceable German aircraft stranded from Norway to Austria, unable to move because they had nothing to burn. Priority rationing made it worse. Many bomber and training units were frozen in place, while fuel was diverted to retreating ground forces. The same air force that had gained rapid air superiority during the invasion of Poland was now helpless. As Allied and Soviet forces advanced, they discovered abandoned fleets at places like Flensburg, Lübeck, and Prague, aircraft intact but permanently grounded. The Allies didn't just want the planes gone, they wanted the secrets inside them. Just as Germany had collected and studied downed Allied aircraft, the Allies formed special teams to capture and analyze Luftwaffe planes. The British created the 1426 Enemy Aircraft Flight, a counterpart to Germany's aircraft testing system. Germany had facilities like Erprobungsstelle Rechlin, their version of Britain's Royal Aircraft Establishment. Allied teams worked to secure German aircraft for intelligence, studying what they could do, how they were built, and where they were weak, just like the Germans had done with captured B-17s and B-24s. When Allied engineers got hands-on, they found German designs weren't all miracle machines. Some were clever, some were deeply flawed. Aircraft like the HE-177 suffered from unrealistic demands, but captured Me-262 jets offered priceless clues about turbojet technology. Testing at places like Wright Field, RAF Farnborough, and Freeman Field revealed both smart innovations and serious problems. And when the Luftwaffe was fully disbanded in 1946, the Allies gained wide access to what remained for deeper evaluation. At the same time, the Allies launched missions to grab German aircraft, documents, and research before it disappeared. Operation LUSTY became the backbone of this effort. The US Army Air Forces sent specialized teams to gather enemy aircraft, weapons, and paperwork. Colonel Watson's Team 1 focused on collecting aircraft. Colonel McCoy's Team 2 focused on people and facilities, recruiting experts and investigating where the tech had been made. Then came one of the wildest moments. A group called the Whizzers convinced German pilots like Karl Bauer and Ludwig Hoffmann to fly 9 Me-262 jets from Lechfeld for American evaluation. These aircraft, including one nicknamed Marge, were studied at Wright Field and Patuxent. Allied technical units worked close to the front lines, finding crashed aircraft and rebuilding them for test flights. They looked for weaknesses, studied production methods, and measured performance. German test pilots like Hans-Werner Lercher also shared insights from their own flying experience, including flights in captured Allied aircraft like the Lancaster and the B-17. Even though Germany lost, Luftwaffe jet ideas still left fingerprints on the future. Swept-wing concepts explored by German designers helped solve high-speed flight problems. Messerschmitt's P1101 variable sweep wing idea became especially influential, laying groundwork for later swing-wing aircraft. Tailless and flying wing concepts, even with stability issues, planted seeds for future stealth thinking. Engine layout ideas, first seen in the HE-178 and refined in the Me-262, helped shape basic rules of jet design. High-altitude interceptor concepts were studied too. The Allies didn't admire Nazi Germany, but they did study anything that could matter in the next war. Then the real cleanup began, and it was not gentle. After Germany's unconditional surrender, the Allied Control Council moved quickly to dismantle what remained of the Luftwaffe. On September 20, 1945, they issued Proclamation No. 2, officially dissolving the Wehrmacht and grounding all German aircraft. The directive left almost no room for exceptions. Fighters, bombers, transports, trainers, everything was included. Only aircraft with major technological value were spared immediate destruction, with examples shipped to the United States for evaluation. Between 1945 and 1948, German airfields turned into scrapyards, as thousands of aircraft were destroyed step by step under Allied supervision. Air disarmament wings guarded equipment until destruction was complete, making sure Germany kept zero military aviation power. This was the final chapter for what had once been one of history's most feared air forces. Across Germany and Northern Europe, vast aircraft graveyards formed, as thousands of planes were concentrated at major airfields for disposal. Teams dismantled valuable parts, crushed fuselages, and burned wooden sections. German prisoners often did the labor under supervision. The Allied Control Council ordered the destruction of all remaining German aircraft by late 1945, saving only the most valuable examples for research. The disposal of over 1 million tons of military materiel left environmental damage behind. Engine oils, chemicals, and residue from weapons and ammunition seeped into the soil at makeshift scrapyards. Colossal disposal centers appeared across Northern Europe, filled with rows of surrendered aircraft, waiting for the same end. Some aircraft were cannibalized for parts. Others were reduced into raw materials to help rebuild a shattered continent. The scale was staggering. Daily operations could handle hundreds of tons of metal as workers crushed, burned, or dismantled airframes. From 1945 to 1948, the disassembly ran like factory work. At sites like Holzkirchen, Messerschmitt Bf 109 fuselages were smelted into raw materials by mid-1948. Workers stripped engines, instruments, radios and armaments before melting aluminum airframes into ingots for shipping. And that speed came with a cost. These scrapping operations focused on speed and metal recovery, not environmental safety. Large stockpiles of metal flowed into post-war rebuilding industries, but the ground under many airfields carried the scars for decades. Across Europe, airfields became makeshift scrapyards filled with remnants of Hitler's air force. You'd find aircraft in different states, fighters here, giant transports there, depending on what was abandoned and where the front lines had moved. Cleanup varied by location. Some bases were cleared quickly, others stayed littered with wrecks and unexploded ordnance for years. Some sites found new uses. Klagenfurt became a cannibalization yard, where parts from damaged trainers kept other aircraft flying for a while. As Allied personnel levels dropped in late 1946 to 1947, cleanup slowed. Many airfields were eventually repurposed, turned into housing, industrial land, or even test tracks. Recycling the planes became its own massive industry. Workers removed engines, instruments, radios, and weapons first. Then they processed the aluminium airframes. Wings and tail fins were clipped off so pieces could be stacked and shipped more easily. Parts from European airfields were shipped for recycling into consumer aluminium products. The work was often done by German POWs. Workers sometimes wore masks while handling dangerous materials, including chemical weapon casings that had to be emptied before the metal joined the recycling stream. Most aircraft not reserved for research faced this same dismantling and smelting process. This scrapping brought real economic benefits too. Over 1 million tons of metal helped repair post-war shortages. The dismantling created jobs for veterans and locals during the hard shift to peacetime. It supplied aluminium and steel to factories and rebuilding projects, while clearing airfields for civilian use. The metal payoff was huge. Scrapped materiel, including tens of thousands of tons of flak equipment and countless airframes, helped feed machinery production and construction across Europe. And the work created employment. Former soldiers worked at dismantling hubs, where temporary worker communities formed around the scrapyards. Veterans with technical skills also found roles in evaluation programs, using their experience to test, inspect, and reverse engineer captured aircraft and parts. Even after early dismantling, jobs continued through maintenance of aircraft briefly repurposed for civil use, and through secondary markets for salvaged parts. The process, from stripping equipment to processing metal, created many types of work for many skill levels. Not every Luftwaffe-related aircraft story ended in a furnace. In Czechoslovakia, production continued in a strange way. After Germany's defeat, Czechoslovakia had intact facilities. The Avia factory, a Skoda Works subsidiary, had produced Luftwaffe aircraft during occupation and kept the ability to build more. At first, they assembled leftover Bf 109G10 components as the S-99, completing 21 single-seaters and 23 two-seat trainers. Then, a warehouse fire destroyed the remaining DB605 engines. Engineers adapted the Junkers Umo 211F bomber engine instead, creating the S-199. That change caused serious problems. The heavier engine shifted the balance, making takeoffs and landings dangerous. Handling was notoriously poor, and control problems were common. Top speed dropped to 590 km per hour. Worse, synchronization issues could cause pilots to shoot off their own propellers. The S-199 earned nicknames like Mezek, meaning mule. Still, Czechoslovakia produced over 550 aircraft between 1947 and 1949, exporting 25 to the new Israeli Air Force. Spain took another path with Messerschmitt fighters. In 1942, Spain secured a license to produce the Bf 109 G2. But Germany delivered only 25 incomplete airframes and partial documentation. Hispano Aviation adapted the design to use a locally produced engine. The first HA 1109 J1L flew in March 1945, armed with twin 20mm cannons and rockets for operations in Africa. Development continued. The HA 1112 K1L added 12.7mm Breda machine guns in May 1951. By 1951, the improved HA 1112 K1L Tripala entered service with a stronger engine. Then came the most ironic version, the HA 1112 M1L Bouchon in 1954, powered by a Rolls-Royce Merlin engine pairing a Messerschmitt airframe with the engine of its former British enemy. Spanish Messerschmitts served until 1965, then appeared in the 1968 film Battle of Britain, preserving their shape for millions of viewers. Some German aircraft also had brief civilian lives, but it was limited. After 1945, thousands of German aircraft took different paths, yet only a small fraction found new life in civilian roles. The Junkers Ju-52 sometimes received case-by-case approvals for limited transport services across post-war Europe. Few examples of the Focke-Wulf Fw 200 Condor survived beyond 1945. Most were stripped for parts or scrapped. Metal shortages across Europe meant many aluminum airframes were worth more as recycled material than as aircraft. In a few places, limited assembly operations gave former military planes brief civilian use, but parts shortages eventually grounded them. Some bombers, including B-17Gs, were also repurposed into flying bombs under Project Castor, combining wartime innovation with remote control technology. And by 1946, Allied policy and post-war economics made widespread civilian conversion unlikely. So did anything escape destruction? A handful did. Despite systematic efforts to destroy or dismantle Luftwaffe aircraft, a few German warplanes survived into the modern era. Today, there are airworthy Bf 109 fighters, including an E-4N near Bonn and the only surviving prototype airframe in Munich. The Me-262, the world's first operational jet fighter, also survived in limited numbers. Some were discovered with technical documents and later influenced related designs like the Avia S-92. Other rare survivors include the Arado AR-234 Blitz jet bomber and the twin-engine Bf-110. Many aircraft exist only as recovered wrecks, pulled from lakes, fields and crash sites decades later. Interestingly, the JG5 wing has the highest representation among surviving Bf-109s, with about 20 examples preserved worldwide. As of December 2016, around 67 known Bf-109 airframes remained in different states of preservation across multiple countries. Preserving these aircraft is brutally hard. Restoring rare World War II aircraft is one of aviation history's toughest jobs. Museums handle it in different ways, from flying reproductions to slow, careful rebuilds using original plans and thousands of handmade pieces. Some aircraft are especially challenging. The Stuka, for example, has restoration projects that can stall for years because parts are rare, damage is severe, and the work takes massive time and skill. These efforts often depend on volunteers, rare documents, and specialized craftsmen. So if most Luftwaffe aircraft were crushed and melted down, why do their ideas still show up later? Because while scrapyards grew across Europe, a quieter war was starting inside hangars, tunnels, and locked offices. When Germany fell, the real prize wasn't the planes you could see, it was the tech you could steal. Jet engines, wing designs, radar ideas, test data, and the people who understood it all. In 1945, teams from different countries rushed into ruined airbases and hidden factories with lists in their pockets. Some lists were official, some were whispered. The goal was simple: find the best German aviation tech before someone else does. The Americans moved fast, partly because they feared the Soviet Union would take the best parts first. In 1945, the Cold War wasn't official yet, but the race had already started. Some of what the Americans did feels unreal. In certain cases, they got German jets flying again. Then they ferried captured aircraft across Europe to staging fields, and finally to the coast for shipment to the United States. Some of those flights became legend. Me-262 jets were flown out from German airfields to be staged for transport, then shipped to the US for testing and study. And this wasn't done by calm, well-rested jet experts. One story describes how Watson picked volunteer P-47 pilots, men with no jet time, to learn how to fly the Me-262. That's like handing someone a machine from the future and saying, "Don't crash, also bring it home." But the Americans weren't alone. Britain ran its own push to grab German aviation knowledge. A British program called Operation Surgeon focused on exploiting German aeronautics and keeping that expertise away from the Soviets. This wasn't only about hardware, it was about brains. There were lists of German scientists and technicians, and plans to move experts out of Germany so the USSR wouldn't get them. In other words, the war had ended, but the recruiting had begun. Then there was the Soviet side. The Red Army captured huge chunks of territory, including areas tied to German research and testing. And the Soviet Union didn't just want trophies, it wanted working knowledge, engines, tools, and the people who could rebuild the work somewhere else. In October 1946, the Soviets carried out a massive operation called Aviation. It moved more than 2,500 German specialists, plus about 4,000 family members, over 6,000 people total, out of Germany and into the USSR. That mattered because it wasn't one scientist here or there, it was a pipeline, a way to relocate skill, not just steal parts. The United States had its own pipeline too. It was called Operation Paperclip, and it brought German scientists and engineers to the US for government work after World War II. One commonly cited figure is more than 1,600 people over the years after 1945. The reason wasn't just curiosity, it was advantage. Use what Germany had learned and keep it away from the next rival. But here's the uncomfortable part. These programs weren't clean. They were messy. Some people brought over had Nazi ties, and the whole idea still sparks arguments today. Now let's talk about the tech itself. What did everyone want so badly? Start with one word: speed. As planes pushed closer to the speed of sound, they hit problems nobody faced before. Drag spiked. Controls got weird. Wings that worked fine at slower speeds suddenly felt like they were fighting the air itself. German research on high-speed flight became a goldmine. After the war, that research didn't stay locked in Germany. It was studied, translated, and reused. One key idea was wing sweep. Adolf Busemann is widely credited for early swept-wing theory, and he later worked in the United States after World War II. His work became part of how American researchers thought about high-speed flight. Then there's the idea of changing wing sweep. That sounds like science fiction in 1945, but it was already being chased. The Messerschmitt P1101 prototype was captured by US troops in April 1945, and its design later helped inspire the Bell X-5. The Bell X-5 became the first aircraft able to change wing sweep in flight, and it first flew in 1951. That's a straight line from captured wartime idea to Cold War experiment. Not a copy-and-paste plane, but a copy-and-learn moment. Now look at jet engines, because without engines, none of the wing ideas matter. Germany had two major production jet engines during the war, the Junkers UMO 004 and the BMW 003. The UMO 004 powered aircraft like the Me-262 and the Arado R-234. The Soviets moved fast on engines. One key story is the RD-10, a Soviet-built copy of the UMO 004, used in early Soviet jet steps. One clear example is the Yak-15. Early Yak-15 development used captured UMO 004 engines and later RD-10 copies. At the same time, the Soviets pushed a twin-engine fighter path using BMW 003 technology. The MiG-9 used reverse-engineered BMW 003 engines, built in Soviet form. So, in the late 90s, you can see the scramble in metal. Different countries are building first jets, and under the skin, pieces of German engine thinking are showing up. Sometimes directly, sometimes as lessons learned the hard way. But here's what people forget. Stealing tech is not the same as mastering it. A jet engine isn't just a blueprint. It's materials, manufacturing, quality control, heat problems, turbine blades that melt. Factories that must repeat the same part 1,000 times without failure. That's why this became a secret war, not just to grab machines, but to grab the know-how. And that's why the end of World War II didn't feel like the end inside aviation labs. It felt like a starting gun. By the early Cold War, the biggest question wasn't who has the most planes, it was who can turn captured ideas into reliable machines first. Because the next time these countries faced each other, it wouldn't be over Berlin in 1945. It would be jets in the clouds, with new flags painted on them, and old German DNA hidden inside the math, the metal, and the engines.